So in this next part of 1.7, the nuance here is we're not just solving one inequality, but we're solving a couple of them. What this is usually called is a compound, and I'm going to call it a linear inequality, because if we look at what we're comparing it to, right, that's a line, 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 that's a line. So we're still dealing with linear inequalities, but we're trying to solve two at once. All right, and so basically the first two, these guys are what we call an AND statement, because I want this line to be, right, I want negative 13 to be less than that line, but at the same time, and I want this line to be less than 13, right? So this is actually an AND statement. So we're talking about a line between negative 13 and 13. Same thing here, right? Our lines between negative 3 and 3, so that would be an AND statement for us with regard to that. And then, of course, down here you can see the OR. And I'll visually show you that we can't have an AND here. Well, we can probably talk about it now. There's no way this can be an AND because I want this line to be less than negative 4, and then I want this line to be above 4. So if we quickly graph that, here's y equals to 4, and here's y equals to negative 4. There's no way, right? If x is plus 3 is greater than 4, I'm up here. If x plus 3 is less than negative 4, I'm down here. So there's no way to bring it together, as opposed to here, right? Here's 13, and here's negative 13. I'm basically trying to figure out when's this line in between them. So very doable. I can do both. I can be greater. This line can be above negative 13, below 13, so it's an AND. Here there's a separation. There's some values above and below the axes there, visually graphing. How do we solve this, right, without a graph? Because I'm kind of alluding to a graph to solve it. Well, to graph it, or excuse me, to algebraically do this, you just keep playing the golden rule, except here, right, when I subtract 3, I do it not to two sides, but I do it to everything. So if I subtract 3 from everything, we end up with negative 16 is greater than negative 2x, which is less than, right, that would be 10. So that's basically what we have with regard to that one. So I basically just play my golden rule. If I was solving that inequality, right, that would be my first step. If I was solving that inequality, that would be my first step. So what about all three of them together? Well, I'll subtract 3 from everything all at once. And then, of course, next move, be careful, right? I'm dividing by a negative 2, so I do that to everything. So what ends up happening? Well, here we get 8, here we get x, here we get negative 5, but because I divided by a negative, all the signs have to switch. So 8 is greater than x, which in turn is greater than negative 5. So on a number line, we're basically talking about all the numbers between negative 5 and 8. Because I have a strict inequality, we're open and we're open. So my solution set here is negative 5 to 8. All right, and again, we can visualize that. I already kind of preloaded this. What's in red, right, is the 3 minus 2x graph. And here's 13 and here's negative 13. And we do, in fact, see, right, that at negative 5, let me come in a little bit, right? So at negative 5, right, there's where we're equal to. And at negative 8, we are equal to. So between, got to get used to this thing here. So between negative 5 and negative 8, the graph of 3 minus 2x sits between negative 13 and positive 13. So we've got it covered, right? Our algebra is good. Same thing here. Perhaps what I want to do is clear the denominator, so I'll multiply everybody by 10. So that gives us negative 30 less than or equal to 2x minus 5, which is less than or equal to positive 30. And then if we add 5 to everything, we end up with negative 25 is less than or equal to 2x, which is less than, got to be careful there, less than, looks like 35. Divide everybody by 2. Again, there's no negatives here, so we're looking at negative 25 over 2 less than or equal to x, which is less than 35 over 2. So interval notation, we're talking about everything between these, this value and that value, but we are including that guy, right, because we're allowed to be equal to, but we're excluding that value right there. All right, and so visually, if let me just go ahead and try to do that. So let me preload this. So we're talking about 3, and we're talking about -3. I'm going to turn that off and turn that on. Okay, so good. So here's basically our graph. Let me put this in another color so we can kind of compare it. Come on. Red. So there's the line, right? In red, 2x minus 5 over 10. And we can see that it's sitting between -3, right? That's that kind of grayish line, and +3. Where is it sitting? Well, that first value we know to be -25 over 2, about 12.5, -12.5. And the other one is about 17.5. Well, so you can see it's close to 20. So it seems, right, that my graph is right on the money. So there's about -12.5. We're above -3, but we're below, right, 17.5. And then there's 17.5, and then we start getting above it. So there's my solution to that guy, and we're off to the races, and we are running. Okay, so what about the next ones when I have or statements? Well, don't let that worry you too much. We're just going to end up with 2 separate inequalities to solve, and we'll see that visually. So we basically just solve these individually. So when is x plus 3 less than -4? Well, if we subtract 3 from both sides, we get x is less than -7. So that interval is -infinity to -7. Or, right, this guy, when is x plus 3 greater than 4? Subtracting 3 from both sides, right, we get x is greater than +1. So that would be from 1 to infinity. Okay? And so, again, if we were to graph this, the line x plus 3, let me preload some stuff here. Okay, so let me zero in so we can see that a little better. Okay, so there's basically the graph of the situation. Now again, we want to know when we're less than -4. So this line, right, x plus 3 has to be below -4, which is this gray line. So that's occurring right at -7. At -7, the graph of the line is below -4. So that interval looks good. And then if we come to the other side, right, at 1, right, the graph of the line actually is bigger than 4, right? And so we basically have from 1 to infinity. So my algebra is right on the money, right? And then last but not least, again, since we have an or statement, we basically just solve these 2 separately. So solving this one, probably our most likely, our good first move is to add 5 to both sides. So this gives us 1/2 x is less than 2. Multiply both sides by 2, we get that x is less than 4. So -infinity to 4 is one of our solutions. Union, if we did the same thing here, add 5 to both sides, we get 1/2 x is greater than 8. Multiply both sides by 2, we get x is greater than 16. So 16 to infinity. All right? And so in this interval, the line is below -3. In this interval, the line is above +3. So let me go ahead and just simulate that so we can know that our algebra is good and we can trust it. Sorry, I should have probably preloaded this before I cut the video. All right, so here we are. So in red, let me zoom out of here. So in red is, right, so in red is basically the line 1/2 x minus 5. We can see that at 16, right, that's that location there, the graph of the line is above a +3. And then if we go in this direction at that location, which we know to be at 4, right, let me zoom in a little bit. Dang it. So there's x equals to 4, right? The graph of the line is above. So it's basically, the graph of the line is below -3 from starting at 4 going to its left. It's above +3 going to its right. So again, visually, the graph seems to justify what we did algebraically. And again, hopefully I've shown you, right, that solving linear inequalities, you essentially have two ways to do it, right? You use the 5.6 idea where you solve where they're equal and test intervals, or you basically use the little nuances, solve, be careful when you divide by a negative or when you multiply by a negative, flip signs, that way you're okay. So your choice as you do your quizzes in 1.7, use 5.6 ideas, use 1.7 ideas. Either way, right, you're going to get the right answer and you'll be solid. Please just make sure you're showing your work. All right, so next part of this section is to talk about absolute values, but obviously we'll do that in a video coming soon.